All right, thank you so much. Hey everyone, I'm very excited to be here. It's a good follow-up to the last presentation. I'm currently in Miami on vacation, working remotely with some nice weather to enjoy later. So we're going to talking about scaling a data lake gracefully in a couple ways with both lakeFS, which is an open source project that I'm a developer advocate for, and also building on one of the previous talks, also modern table formats like Data Lake. So, okay. So the agenda we're going to cover is relatively straightforward. First, we're going to discuss why object stores, which are the basic foundation of a data lake, are so popular and, in my word, amazing. And then 2 ways they can be optimized for the specific use cases of large scale or big data analytics. And if time and I can figure out the screen sharing, I'll try to hop into a quick demo showing both lakeFS and Delta in action. So, okay. So starting with why object stores are amazing, why I love them. And to be clear, we're talking about the major object store providers like Minio, Google Cloud, Azure Blob, and S3. They're awesome in terms of a number of factors like performance, being cost effective, they have a great developer experience, and they're easily integrated with a wide variety of tools. Their use has become pretty much ubiquitous in a number of use cases. And in my opinion, we sort of take object stores for granted. And so I'm happy to run real quick over some of their specific strengths here. They automatically scale to a high number of requests per second per prefix. Behind the scenes, there's no like horizontally or vertically scaling or sharding a database involved. They're pretty much always available. You're paid for the storage itself and any network activity that occurs. Roughly speaking, they are typically about 5 to 8 times cheaper than your typical block storage. They have mature client SDKs in pretty much every language to read and write data to them. In the last year, at least Amazon's S3 released strong consistency, giving consistent reads after writes. You can get very helpful usage metric dashboards on your usage, and they are much more than just storage itself. You can set up like event triggers or very granular permissioning, data replication policies, and finally, whatever tool you're using, be it a warehouse or some query engine like Spark, it's a well-trodden path to connect to them and read and write, making it very easy to integrate. So my little transition here isn't working in this view, but that's okay. But lakeFS, that's our little axolotl logo, also integrates with object stores as well. And so for all these strengths, the question remains, how do they scale for more complex workloads required by like big data analytics and data intensive applications? And the answer is that they don't without some what I call optimizations that let you scale gracefully. The first are modern table formats, and the idea is to maintain a transaction log stored as metadata alongside data in the object store that a query engine can make use to provide these benefits. I think it was James before covered this as well for Delta Lake. 2 other popular implementations are Apache Hoodie and Apache Iceberg. And this graphic is from the Delta Lake blog. You can see that it has the files of data themselves, like file1.parquet. And on the upper part is this transaction log called the Delta log that very straightforwardly is saying file1.parquet was added here. And this lets you avoid some silly errors that occurs when using object stores, like what happens when I read a file as one is being written. Without these formats, you would get either like a query error or maybe some weird results because like half the file was written. So this provides transaction isolation that is very useful, along with some of these other benefits. The next optimization is an even newer category called data source control. The idea here is to extend object store operations with those of Git to provide a number of benefits, like fixing bad data instantly, getting a nice isolation development environment that's a complete replica of your data. And two implementations of this are lakeFS and Project Nessie. One way I like to think about this is to think of what you're capable of doing in an object store by itself. Here's a screenshot of the S3 user interface. You can copy a file, you can move a file, you can delete a file. But what if you could also do a few other things, like create a branch of your data set or create a commit of this data? This is essentially the idea here. Here's a new screenshot of the lakeFS UI, where it is sort of a mishmash of something like GitHub and an object store. You see the data stored similarly, but we have these new tabs for committing and branching, etc. This provides a number of benefits that I have delineated here. The respective sort of Git command, in our case, it's the lakeFS command line tool called lakectl. For example, if you want to reproduce your data at a specific point in time, you don't have to sort of filter your data on some timestamp, which can be a little complicated. Each time you take a commit, there will be a generated commit ID, and you can read in your data set at that exact time for very simple reproducibility. So I'm not sure I can even see. I'm not going to go through the quick demo. I will be happy to share a YouTube link that shows me pretty much going through the exact same demo, but basically I'm showing this sort of Git inspired workflow for working with data where I want to make a change to a data set. There's no need to copy the data somewhere else or save the results in some separate location. We instead do the more elegant workflow of creating a new branch for this change to take place in and be tested, save the new results there, perform any testing I like, and if it looks good, you can create essentially a pull request to merge the new data into what is more like the main production data set. Some quick last core principles of lakeFS that are its strengths. We are intentionally designed to handle scale. The big issue with Git is that it cannot version data files in the same way that it versions code, but we have designed a proprietary, and we're open source, but a bespoke data model that lets us version and have this source control for large files. We work with any data format and as well as any object store. And we sit at the infrastructure level of a data stack where it's very easy for any tool you're using to easily read and write data from lakeFS. This is well, it's not a high level, it's a very detailed diagram of the data model we use that maps from branches to commits, and then to eventually at the bottom, the objects themselves. And you can see how we're reusing these meta ranges and ranges of files as much as possible between commits and branches. So data replication or data duplication is minimized between this, and it's a key part of our scalability. So that's the presentation. You can follow me at DataWisp on Twitter. You can read more about lakeFS at lakeFS.io. Thank you so much. It's been fun.